Okay, so in our last lesson we talked about similar polygons. In this lesson we're going to focus more on just proving that triangles are similar, only triangles. So there are a couple theorems. We're going to make a graphic organizer for all three of these theorems so that you don't have to necessarily memorize them, but you can actually use something to help you apply these theorems. So we're going to use the AA postulate. I will explain what that is. Also the SAS and SSS similarity theorems. And we're going to use similarity to help us find indirect measures. So the first theorem, or postulate we're going to talk about, is called AA, which is angle-angle similarity. It's a shortcut to prove triangles are similar. And it states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles must be similar. Because if you think about it, if S is congruent to M and R is congruent to L, then T has to be congruent to P. So all of the angles are congruent. In triangles, if all three angles are congruent, then the triangles must be similar. So in example 1, we are going to determine whether these two triangles are similar and how we know they are similar. So the first thing that we see is that angle R and angle V are congruent because they're both 45 degrees. The next thing we can say is that WSR, this angle, and VSB are congruent because they are vertical angles. So we can say that, and I'm going to be careful with how I name this, we can say that triangle RSW, so I'm going to start at the 45 degree angle, is congruent to triangle VSB by AA. Angle R is congruent to angle V because that is given, and I'm going to be careful with how I name these angles. Angle RSW is congruent to angle VSB by vertical angles. Those are vertical angles. So we can say those triangles are congruent by AA. Two angles are congruent. Two pairs of angles are congruent. So as far as guided practice goes, you're going to do the same thing. Are the two triangles similar? And how do you know? So work through A and B on your own. Pause the video before you start working through them. When you're ready, resume the video, and I'll explain the answers. Okay, so long story short, A is yes, B is no. In A, the triangles are similar because if I do 90 minus 39, that third angle is 51, and I have a pair of congruent angles because these are both 90. I have another pair because these are both 51. So they're congruent by AA because I have two pairs of congruent angles. In part B, I found all three angles of each triangle just to prove that it doesn't even have a single pair of congruent angles, so that's why it's no. There's not even one pair of congruent angles. So these triangles in part B can't be similar by AA. So knowing that this is isosceles, this other angle in the first triangle is 68. 180 minus 68 is 44. In the other triangle, each of these angles, since it's isosceles, are 59 because 180 minus 62 divided by 2 is 59. So no pairs of congruent angles, not similar by AA. The next two theorems are a little bit tougher to wrap our heads around, so I'm going to spend more time practicing these and explaining these. So the first one is side angle side. And it states that if one angle of a triangle is congruent to another angle of the second triangle, and the sides that include the two angles are proportional, then they're similar. So that means if A and Q are congruent, and the corresponding sides that include A and Q are proportional, these triangles are similar. For side, 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 it's a kind of similar to angle, angle, but it's saying that if the corresponding sides are proportional, just the sides, no angles given, just the sides are proportional, then the triangles are similar. So either two angles are congruent and the included sides are proportional, or all three sides are proportional to all three sides of another triangle. So that proves SAS, SSS. Talking about it right now doesn't really help us understand it. So I'm going to go through some examples on the back side of these notes and try to explain it, and then hopefully the practice kind of helps. And when I'm back in class, obviously, I'm going to be able to help you guys explain this a little bit more too. This lesson does not necessarily end today. So, verifying if triangles are similar. If I look at part A, I'm looking for side, side, side because I'm given 3 sides. So, in example 2, I'm going to compare, 6 to 9 because those are the shortest sides. So 6 over 9, those would correspond. And then I would compare 8 and 12. And then I would compare 10 and 15. So basically the smallest side compared to the smallest side. Simplifying this, 6 over 9 becomes 2/3. 8 over 12 becomes 2/3. 10 over 15 becomes 2/3. So triangles are similar. And I'm going to say just the statement, the similarity statement. I'm going to say triangle STU is similar, and you've got to be careful with how you name it. STU is similar to XVW. That listing is important because ST, XV, TU, VW, and then US, WX are corresponding. And they're similar by our SSS theorem. Okay? They're similar by that theorem. Okay? So in part B, this is a little bit harder to look at. But when we look at this, it's understanding that KLP, and I'm just going to write it right here, KLP is in triangle inside triangle, KMN. We're seeing if those are similar. So the first thing I can say, it's kind of weird to say, but K is congruent to itself. So it's possibly going to be SAS if this works out. Now the part that's going to be confusing is writing out this ratio, or this proportion. So in the smaller triangle, 8 is one of the sides. In the bigger triangle, 10 is the corresponding side because 8 plus 2 is 10. Alternatively, I'm going to do 12 over 15 because 12 is the smaller side, 15 is this full side. So that's why I set up that proportion of 8 over 10, 12 over 15. These, when I simplify them, this becomes 4 over 5. This becomes 3 over 5. That is not a true proportion, so these are not similar by SAS. If these were the same proportion or same ratio, these are proportional, these sides, I could say they were similar by SAS, but they're not, so I can't say they're similar by that theorem. Again, we will get practice on this. Hopefully it will get better as we go. As far as the guided practice, I tried the best I could to give you problems that were similar to the last example. So please try them. Pause the video, try them, and then resume the video when you're ready for me to explain it. And again, we will go through more examples of these. We will cover this when I'm back and we're in person together. So just work through this best you can. Resume the video when you're ready to move on. So to explain these two examples in the guided practice, they're both similar. The first one is similar by SSS because all 3 sides are proportional. Okay, all 3 pairs of sides are proportional. In part B, we have an included angle, and the sides for that included angle are proportional. 8 over 16, 6 over 12. They are proportional. So that's why the first one was SSS because we had 3 sides. Second one was SAS because we had 2 sides and an included angle. Now in example 3, it's kind of a wacky example, but it says, before rock climbing, Darius wants to know how high he will climb on this cliff face. He places a mirror on the ground and walks backwards until he can see the top of the cliff in the mirror. What is the height of the cliff? So to set this problem up, I'm going to have 2 ratios here, or a proportion that compares 2 ratios, because these are going to create 2 similar triangles. So I'm going to compare the height of the cliff, which is x, to Darius's height, which is 5.5. On the flip side, I'm going to compare the distance from the mirror to the cliff to the distance from Darius to the mirror. So I'm really comparing measurements of Darius and the cliff, his height versus the cliff's height. Okay, So Cliff's height is on the top, Darius's height is on the bottom. Cliff's distance from the mirror, Darius's distance from the mirror. So to set this up, it's going to be 6x equals 34 times 5.5, which is 187. And I'm going to divide both sides by 6. So x ends up being 31.166, and that's repeating. So if I was going to do this, I would most likely have you round. So I would say the height of the cliff is roughly, I'd just say 31.17 feet. And most of the time I'm going to ask you for the units in your answer. Normally I'd ask you to round to a certain decimal place. If I don't tell you a decimal place to round to and you do get a decimal, just round to 2 decimal places, okay? Round to the hundredths place. So just assume if I don't tell you to round, assume you can round to 2 decimal places. So just being able to set up a proportion, I compared the heights, the vertical heights, and I compared the horizontal heights in a proportion. So that's where you'd have to find a measure. This is going to be the most important type of problem for you to answer, or type of question for you to answer. So that's why I included this one at the end. So you can move on to practice this, and then eventually when you're ready for the checkpoint. But we will cover this when I'm back in class on Monday and Tuesday.